All right, now problem number 2 deals with section 9.2. Says here, researchers conducted a study to determine whether magnets are effective in treating back pain. The results are shown in the table for treatment with magnets group and the sham or the placebo group. The results are a measure of reduction in back pain. Assume that the two samples are independent, simple random samples selected from normally distributed populations, and do not assume that the population standard deviations are equal. All right, and in this case, here's the table that they give you. And in this case, we're going to use a 0.05 significance level to test the claim that those treated with magnets have greater mean reduction in pain than those given a sham treatment. And then part B is to construct a confidence interval suitable for testing a claim that those treated with magnets have greater mean reduction pain than those given a sham treatment. Okay, so here's problem number 2. Now they already give you the table, so we don't have to worry about constructing a table here. So part A, we can go ahead and start with the 8-step hypothesis testing. Now, step number 1 would be the original claim. Now, it does say here that we're testing the claim that those treated with magnets have a greater mean reduction pain than those given the sham treatment. Okay, and they tell you what to use for mu sub 1. Treatment, mu sub 2, sham, the sham. Right. So mu sub 1 would be greater than mu sub 2. And then step number 2 will be the opposite of the original claim. So what would be the opposite of greater than? Less than or equal to. So mu sub 1 is less than or equal to mu sub 2. All right, now step 3 is the null and the alternative hypothesis. Okay, so which one would be the alternative hypothesis here? Okay, yeah, mu sub 1 is greater than mu sub 2. And in this case, that is the claim. And mu sub 1, for the null, mu sub 1 is equal to mu sub 2. Null always has the equal to sign in it. All right, now step number 4. Is my level of significance here. Alpha is equal to what in this case? 0.05. And then step number 5, and I might as well say step number 6 as well. We're going to use the graphing calculator. So from the TI-84 plus we're going to be looking for the critical T value, and then from the TI-84 plus, we can get the P value as well. Okay, so to do that, here we're going to press the stat key, go over to test. In this case, we're going to select the 2-sample t-test item, which is this right here, 2-sample t-test. And then press enter. Now I need stats to be highlighted. So if that's not the case here, you want to use your right arrow key, put the cursor on top of the word stats, and then press enter. Okay, because all we have here is summary statistics. So in this case here, for mu sub 1, or x bar 1, you have to go here under the first one, which is the treatment. That's 0.53, so we type in 0.53 there. And then S sub x is the standard deviation of the first, in this case. That's 0.77. And then enter. N1 is your sample size. That's 14. And then go to x2, x bar 2, which is the mean of the second, which is your sham treatment. Here's your x bar right here, 0.42. S of x, that's standard deviation, 1.08. And then N2, sample size of that second treatment, that's 14. Now for the mu sub 1, will it be not equal to, less than, or greater than? Greater than from the alternative hypothesis. So that means I'm going to use my right arrow key to put the cursor on top of greater than mu sub 2 and then press enter to highlight it. Then I'm going to use my down arrow key. It will, for pooled, it will always be no, so don't worry about that. Keep going down. Make sure the cursor's on top of calculate, and then hit enter. All right, so we know what t is. And let's say to 3 decimal places that t-test statistic is what? 0.310. And then the p-value, right under the t is your p, that's your p-value. Let's say to 3 decimal places, what would that be? 0.380. That's your p-value. And now step number 7 is our decision rule. Since we're comparing the p-value, we need to compare that to our level of significance. If the p-value is less than or equal to your level of significance, you're going to reject the null hypothesis. So my p-value came out to be 0.380. The alpha level is 0.05. Is 0.380 less than or greater than 0.05? Here is greater than. So what do we need to do here? Fail to reject the null hypothesis. And then step number 8 is our concluding statement. Now we already failed to reject the null hypothesis. Our alternative hypothesis is a claim. We failed to reject it, so that means there is not sufficient evidence. There is not sufficient evidence to support the claim. That those treated with magnets have a greater mean reduction in pain than those given the sham treatment. Sometimes they call it a placebo. Okay. So that right there is part A. Part B is to construct a confidence interval suitable for testing a claim that those treated with magnets have a greater mean reduction in pain than those given a sham treatment. Okay, so in this case here, we have, do we have a one-tail or two-tail test?
One tail.
One tail. and our alpha level was 0.05. That means the confidence level and let's take a look from this table. We have a one-tailed test. The significance level was 0.05. So that means confidence will be 90%. So now we can use that to get our confidence interval. So in this case here, I'm going to press the stat key, go over the test. Now here we're going to do 2-samp interval t-interval, 2-samp t-interval. So we have to press that down arrow key to find that 2-samp t-interval. Okay, and then press enter. All right, stats should always be highlighted since we're dealing with summary statistics here. X1 bar is 53. Hold on. Okay, I'm right. 0.53. S1, that's 0.77. N1 is 14. X2 is 0.42. 1.08 for the second standard deviation. N2 is 14. Let's use our down arrow key to find the confidence level. This time, we're using 90%. So we need to change this to 90%. Use your down arrow key. Pooled will be no, as always. And then calculate. Make sure the cursor's on calculate, press enter. And there's your confidence interval at the top. Okay. Okay. Okay, so here, let's see, to 3 decimal places, that's going to be a negative 0.497, and that's going to be less than, and in this case, mu sub 1 minus mu sub 2, and less than, let's say the 3 decimal places, 0.717. And as you can see here that this confidence interval does contain 0 because one's negative, the other one's positive, so 0 is in that interval. So that's enough to say that we can fail to reject the null hypothesis and conclude that there is not enough evidence to support the claim that those treated with magnets have greater mean reduction in pain than those given the sham treatment. Okay. Are there any questions on problem number 2? Okay, problem number 3 on the back. A popular theory is that presidential candidates have an advantage if they are taller than their main opponents. Listed are heights in centimeters of randomly selected presidents along with their heights of their main opponents. And here's the data. And then part A, you're going to use that sample data with a 0.01 significance level to test the claim that for the population of heights for presidents and their main opponents, the differences have a mean greater than 0. And then part B is to construct a confidence interval that could be used for the hypothesis test described in part A. All right, so first thing I need to do here is I have to first come up with their differences. And I'm going to put this in here. The difference of each one of these, that's going to be your D. And to find the difference, we always subtract the upper minus the lower. So 180 minus 173 will be the 7. Then 177 minus 71 would be 6. 174 minus 167 would be 7. 179 minus 184 would be -5. 184 minus 184 is 0. 170 minus 172, -2. Now, these differences are the ones we're going to put in our graphing calculator. So let me go ahead and do that right now by pressing the Stat key. Actually, I'm going to edit. So when you press Stat key, under the Edit menu, select number 1 for Edit. And you notice I've got some stuff that's in L1, L2, and L3. So I need to clear all those data values out by using the up arrow key to highlight, and then press Enter and press Clear, then Enter. I'm going to do the same thing for L2. Up arrow to highlight L2, press Clear, Enter. And then up arrow to highlight L1, press Clear, and then Enter. Now these differences will go into L1. And in this case, I'll type in these numbers like 7, then Enter. 6, Enter. 7, Enter. -5, Enter. 0, Enter. -2, Enter. Okay. Okay. So let me put this off to the side, and then we can go ahead and answer problem number 3. Part A. That's where we have to use that 8-step procedure. So step number 1 is the original claim. Now here we're going to have to use mu sub d, because that's the mean of your differences here. Because if you read the problem, it does say that the differences have a mean greater than 0. Well, that inequality would just be greater than 0. That's our claim. And then step number 2, the opposite of the original claim. That's going to be mu sub d is what?
Less than or equal to?
Less than or equal to 0. And then step number 3 is your null and alternative hypothesis. So which one of these will be your alternative hypothesis?
Greater than 0.
Yep, mu sub d is greater than 0. The null mu sub d is equal to 0. Okay. And that mu sub d is greater than 0, that's going to be our claim. So I might as well make a note of that. And then step number 4 is your level of significance. What's your level of significance here?
0.01.
0.01. And now step number 5. We're going to use the TI-84. And we're going to get our t value there. And then step number 6, also from the TI-84. We're going to get the p-value. All right, so we already got our our differences in L1. So from here, we go ahead and press the Stat key, go over to Test, and the one we're going to select is menu item number 2, which is going to be the t-test. Okay, just a t-test. and then press enter. Now, we want to make sure that data, for this one, data is highlighted because we're using data values here. So we're going to use our left arrow key to put the cursor on top of data and then press enter. Our mu sub 0, that comes from the null hypothesis. That's going to be 0. Your list should be L1 automatically. Frequency, that's still going to be 1, so we won't have to worry about that. But for our alternative hypothesis, is it less than, greater than, or not equal to? Greater than. So we want to make sure that greater than mu sub 0 is highlighted. And then go down to calculate, press enter. And there's your t-test statistic and your p-value. So your t-test statistic to, let's say, 3 decimal places, that's going to be what? 1.022. And then for the p-value, right underneath the t-test statistic is your p-value. So the 3 decimal places, what would that value be? 0.177. Okay. And then step number 7, we're going to say if the p-value is less than or equal to alpha, you want to reject the null hypothesis. So 0.177 is your p-value. We're comparing that to our level of significance. That's going to be 0.01. Is 0.177 less than or greater than 0.01?
Greater than.
Here is greater than. So we need to fail to reject the null hypothesis. And then step number 8 is coming up with our conclusion using simple non-technical terms. Well, the claim was the alternative hypothesis. We failed to reject this null hypothesis. That means that there is not sufficient evidence to support the claim. That, and I'm kind of paraphrasing here, that the differences in heights for presidents and main opponents are greater than 0. Okay. So that right there was just part A. Part B says that we need to construct a confidence interval that could be used for the hypothesis test described in part A. So in this case here, do we have a one-tail or a two-tail test? One tail. And the alpha level was 0.01. So that confidence level .01, one-tail test, the confidence level is 98%. Okay. So that means here we go to stat, go to test. Now here we're dealing with we're dealing with the T interval. So we need to go down to T interval, which is this right here. T interval, and then select that, press enter. The data that still needs to be highlighted since we used data values. L1 should be still be L1 on the list. Frequencies should still be 1. The confidence level, here we're using 98%, so we need to change this to 98%. Press enter, and then press enter again to calculate this. Okay. So, excuse me. So here we got my lower limit, negative 4.967. And I'm doing this to 3 decimal places. That's going to be less than. And here we're using mu sub d. And that's going to be less than. To 3 decimal places, that would be 9.300. So here we're 98% confident that the true mean differences in heights for presidents and main opponents fall between negative 4.967 and 9.300. And pretty much you can see that 0 is in between those two. Since one's negative, the other one's positive. So 0 is in there, so that means we can fail to reject the null hypothesis and say that there is not sufficient evidence to support the claim that the differences in heights for presidents and main opponents are greater than 0. Are there any questions about problem number 3? Okay, so problems 4 and 5 deal with correlation and regression, which is chapter 10. So number 4, listed below are the numbers of internet users per 100 people and numbers of scientific award winners per 10 million people for different countries. Determine whether there is sufficient evidence to support a claim of a linear correlation between the two variables. And you're going to use a significance level of alpha is equal to 0.01. So pretty much for that one, it's just the 8-step procedure for hypothesis testing. So step number 1 is just writing the original claim in symbolic form. Now, we have to use the Greek letter rho since we're dealing with a correlation, linear correlation. And we want to determine whether there's sufficient evidence to support the claim of a linear correlation. So that means not equal to 0. Not equal to 0 for rho not equal to 0, meaning that there is a linear correlation. What would be the opposite of this claim? Equal to rho equal to 0. That means that there is a linear correlation. There is no linear correlation. Don't get those confused. Not equal to means that there is a linear correlation between the two variables. Equal to 0 means that there is no correlation between the two. Step number 3. Your null and your alternative hypothesis. Which one will be the alternative hypothesis? Not equal to. And that's also your claim as well. The null always has the equal to sign, regardless. So it'd be rho equal to 0. So that's step number 3. Step number 4 is your level of significance. What would that be? 0.01. And then step number 5 is using a TI-84 plus calculator. That's to find out what your linear correlation coefficient is. We want to find out what R is going to be. So to do that, we're going to press the stat key and then select number 1 for edit because we're putting in brand new data values here. So let me clear L1 out by using the up arrow key, hit clear, and then press enter. Okay. Now, that first row is the internet of users. I'm going to put that in L1. Okay. So under L1, I'll put in the internet users, that's 80.4, then 80.8, 57.5, 67.7, 79.4, 38.5. Okay. And then the award winners, I will put those values in L2. So right arrow over to L2 and type in those data values: 5.5, 9.1, 3.4, 1.6, 10.7, 0.1, and then enter. And you want to make sure that you have the same number of data values in L1 as you do for L2 because those values correspond to each other or correlate to each other. Okay, so to find out what that linear correlation coefficient R is going to be, what you'll do here is press the stat key, go over to test, and then you're going to go all the way down to LinReg t-test. That's short for linear regression t-test. Here it is, LinReg t-test. And then press enter. Let's see, X-list should still be L1, Y-list should still be L2. The frequency is, it's going to be 1. Now for the beta and the rho, that's for the regression. You have to look at your alternative hypothesis, which is in this case, not equal to. So you want to make sure that not equal to is highlighted. So use your down arrow key, put the cursor on top of not equal to 0 and press enter. This we can leave blank. Calculate is the one you want to highlight or put the cursor on top, then press enter. All right, in this case, we're going to have to use our down arrow key because there is more stuff here that can be fitted on this screen. Go all the way down, you'll see where your R is. That's your linear correlation coefficient. Enter 3 decimal places, what would that value be? 0.810. So that's your linear correlation coefficient. Now, step number 6. This one's going to be a little bit different. We're going to use a critical value approach. And I will provide table A6 on your help sheet. So here is table A6 right here. I know that's hard to see, but let me see if I can get this glare out. Yeah. Okay. You look under N, which is the number of paired data values that you have, and you're going to use either the 0.05 significance level or the 0.01 significance level. What significance level do we have here? 0.01, and there are 6 paired data values. So read across and down, what would be your critical value? 0.917. That's your critical value. Now I can turn this light back on. And then step number 7, the way you're going to do the decision rule is going to be this. If the absolute value of your linear correlation coefficient, which is R, if it's greater than your critical value, reject the null hypothesis. And that decision rule will be on here, because it says right here, to test HO, which is rho is equal to 0, against H1, which is rho not equal to 0, reject the null hypothesis if the absolute value of R is greater than the critical value in the table. Okay, so now R is 0.810, and the absolute value is always positive. So the absolute value of 0.810 is 0.810. Our critical value, 0.917. Is that less than or greater than? Is R greater than or less than the critical value? Here's less than. It fails our decision rule, so we need to fail to reject the null hypothesis. Fail to reject the null hypothesis. And then our concluding statement would be something like this. We failed to reject the null, and the claim was the alternative, so that means that there is not sufficient evidence to conclude that there is a linear correlation now I'll just say between the two variables. And if you wanted to be more specific, you could say between internet users and award winners.
I got a question.
Yes.
Can you tell me again how to get to the table when you put them into the L1 and L2? Like, how do you get to that on the chart page? What's the buttons for?
Okay. Go stat. If you're putting in brand new,
Edit?
yeah,
Okay.
and then edit.
Okay.
Okay. Any other questions? Okay, and finally, problem number 5. The data shows the bug chirps per minute at different temperatures. Find the regression equation letting the first variable be the independent or the x variable. Find the best predicted temperature for a time when a bug is chirping at a rate of 3,000 chirps per minute and use a significance level of 0.05. All right, so in this case here, we'll start up by finding out what the regression equation is. And of course, that's y hat is equal to ax plus b. All right, and here we're going to type in those data values here in the calculator for problem number 5. All right, so we press the stat key and then number 1 for edit. All right, and then we need to clear this data, all the data in L2 and L1. That first row will be L1. That's your X or your independent variable. So we type in 942, 1172, 1000, 1119, 945, 774. And then use the right arrow key to go to L2 and enter those data values in. So here we got 79.3, enter, 90.3, enter, 81.2, 82.8, 73.6, and 66.5. And you want to make sure that the number of data values you have in L1 are the same as the number of data values in L2 because they correspond to each other. Make sure your data values are entered correctly as well. Now to find the regression equation, we do this. We press the stat key. Use your right arrow key to find this, to highlight this menu that says calculate, C-A-L-C. The menu item you want is this one, linreg AX plus B, because that will give you the linear or the regression equation. Then press enter. X list should be L1. Your Y list should be L2. Frequency list and store regression equation, those can be left blank. Go all the way down to calculate and press enter. And you're given the Y equal AX plus B, and you're told what A is and what B is. And we're going to round those off to 3 decimal places. So for the A to 3 decimal places, that would be what? Anyone?
I didn't see the linreg AX plus B.
That's should be number 4. Under calculate, linreg.
Oh, under calculate. I was
Yeah.
looking at the text.
Okay.
You said 3 decimal places or 2?
3.
0.055.
Correct. And that's going to be the coefficient of X plus B to 3 decimal places will be what?
24.857.
Right, 24.857. And sometimes they write it with the numerical term first and then your linear term right behind it. Might have seen that in the homework because they sometimes do that for your regression equation. So that's the regression equation. Now I'm going to use the 8-step procedure to determine whether we have a linear correlation between the two variables. And if that's the case, we can use this regression equation to find the best predicted temperature at the rate of 3,000 chirps per minute. So step number 1 is the original claim. And in this case here, that's going to be rho is not equal to 0, meaning that there is a linear correlation. Step number 2 is the opposite. And that's, of course, rho is equal to 0. And then the null and the alternative, which one will be the alternative? Rho is does not equal to 0. Rho is equal to 0. That's going to be your null hypothesis, as always. And now they say, well, what's our level of significance here?
0.05.
0.05. Then number 5, we'll get our linear correlation coefficient from the TI-84 plus calculator. So to get that, we're going to press stat, go over to test, go down to linreg t-test. And then press enter. L1 and L2 should be your X list and Y list respectively. Not equal to 0 should be highlighted under beta and rho. This should be blank. Go all the way down to calculate. Press enter. Go all the way down to find R, which is in this case to 3 decimal places.
0.950.
0.950. I do want to tell you that you could get A and B from this Linreg t-test, because here's A and here's B. Already there. But here they got it as A plus BX. Under the Linreg AX plus B is swapped. Okay, now step number 6 is using that critical value approach that we used in problem number 4. So we're going to use table A-6 to get the critical value. So from that table, how many paired data do we have here? There's 6. This time, what's our level of significance? 0.05. So the critical value will have to be 0.811. And then that decision rule is this: if the absolute value of R is greater than our critical value, we're going to reject the null hypothesis. And R from step number 5 was 0.950. And of course, the absolute value is positive, so it'll be still 0.950. The critical value is 0.811. Is that less than or greater than? Greater than. So we need to not fail to reject.
Oh, yeah, reject.
Reject, because it does satisfy the decision rule. So that means we need to reject the null hypothesis. And if we reject the null hypothesis, that means we're supporting the claim. We're supporting the fact that there is a linear correlation. So that means that there is sufficient evidence to conclude that there is a linear correlation between, I'm saying chirps per minute. Here I'm just saying that what the two variables are, and temperature. All right, so now we know that there's sufficient evidence to conclude that there's a linear correlation. We can go ahead and use the regression equation that we got up here and find out what that best predicted temperature. Okay, so best predicted temperature we're going to find that out by using that y hat is equal to 24.857 plus 0.055x. And in this case, our x is 3,000, because in the problem it does say find the best predicted temperature for a time when a bug is chirping at the rate of 3,000 chirps per minute. So x is 3,000. We just substitute the x in this regression equation with 3,000. So using the calculator, let me clear. 24.857 plus 0.055 times 3,000. One too many zeros. And if I was to round this off, let's say to one decimal place, it would be 189.9
No.
degrees Fahrenheit. So the best predicted temperature would be 189.9 degrees Fahrenheit. And that temperature is kind of unrealistic in reality. Yeah. Mhm. Okay. Are there any questions about problem number 5?
Pictures at the top of the paper.
Okay. Or does anybody have any questions about what will be on your exam number 4?